Hello, and welcome to Science with Mr. Morgan. In today's episode, we're going to be learning about the solar system, part 3. First up, we're going to talk about extrasolar planets, otherwise known as exoplanets. Now, these are outside of our solar system, but we're incorporating it here. So have you ever wondered if there are planets outside of our solar system? The answer is yes, like I just said. These planets, these exoplanets, orbit stars other than our sun. And scientists have been detecting exoplanets for decades, and the numbers just keep growing. Way back, in what seems like so long ago now, April 2014, astronomers had found about 4,600 exoplanets, with 1,706 officially confirmed. Fast forward to January 2021, and these numbers jumped to 8,981 discovered, with 4,341 confirmed. But how do we even find these planets? After all, they're tiny and extremely far away. Astronomers end up looking for things like telltale signs. These include tiny wobbles in a star's motion. While stars pull on planets, which is what keeps us orbiting around the sun, planets also pull on the stars. And this gravitational tug of war gives away the presence of orbiting planets. And here's the big question. Could these exoplanets support life? One of the most promising candidates is Kepler-22b, and this exoplanet is located in the Goldilocks zone. And this is the zone that is the perfect distance from a star where conditions can be just right for liquid water and possibly life. Earth is in the Goldilocks zone of our sun. Now that's enough about exoplanets. Let's take a look at asteroids. When the sun and planets formed, not all of the materials were used up. Some chunks of rock and metal never got pulled into a planet or a moon, which leaves us with asteroids. Now, asteroids are small, irregularly shaped, and more like giant space rocks than planets. They lack the gravity strong enough to become round, they don't have atmospheres, and they experience no internal heat or geologic activity. The only thing that really changes asteroids are collisions. If an asteroid drifts too close to a planet or a moon, gravity might pull it in, leading to an impact. And where do we find most asteroids, you might ask? The asteroid belt. This is a vast region between Mars and Jupiter that contains thousands of these rocky remnants. Remember, the farther out in the atmosphere you go, the less rocky stuff there are, and it's more gaseous. Anyway, despite their numbers, their total combined mass is only about 4% of Earth's moon. So there's a lot of them spread out, but it's not that much mass. And some asteroids have orbits that bring them close to Earth. These near-Earth asteroids occasionally collide with our planet. In fact, every year small asteroids of about 5 to 10 meters, aka 16 to 33 feet in diameter, hit Earth each year. Some asteroids are 500 to 1,000 kilometers in diameter. And when asteroids this big hit Earth in the past, many organisms died, causing mass extinctions. So why do scientists care about asteroids? Well, besides studying them for clues about our solar system's formation, since they're relatively unchanged from when the solar system formed, asteroids one day may be mined for valuable minerals or even used in future space construction projects. Now, besides asteroids, let's take a moment to talk about comets. Unlike rocky asteroids, comets are icy objects that travel on a highly elliptical orbit around the sun. They spend most of their time in the outer solar system, only becoming visible when they venture close to the sun. Early on in Earth's history, comets may have played a crucial role in bringing water and organic compounds to our planet through their impacts. Now, one signature part of a comet is their tails. As a comet nears the sun, its outer layers of ice melt, creating a glowing coma. The solar wind then pushes the gas and dust outwards, forming a tail that always points away from the sun. Meteors, meteoroids, and meteorites are what we're going to talk about next. Have you ever been outside at nighttime and looked up and saw a shooting star? If you said yes, surprise, it's not a star at all. What you're actually seeing is space debris burning up. And in the case we're talking about now, you're seeing a meteor, a small piece of space debris burning up as it enters through Earth's atmosphere. Now, before meteors enter Earth's atmosphere, these are called meteoroids, and they can be as small as grains of sand or as large as boulders. Sometimes Earth passes through a comet's tail, which creates a meteor shower, that dazzling display of streaking lights across the night sky. And if a meteor doesn't fully burn up in the atmosphere and the core makes it all the way to the ground, it's called a meteorite. Let's take a step back and we're going to revisit planets for a minute. In 2006, the International Astronomical Union refined the official definition of what makes a planet a planet. So to be considered a planet, an object must meet the following. It must orbit a star. It must be big enough for gravity to make it spherical. It must be small enough that it isn't a star itself. And it has cleared the orbit of other debris. That's an important one. In order to be considered a dwarf planet, an object must also orbit a star, have enough mass to be nearly spherical, not quite all the way there, but nearly there, and not have cleared an area around its orbit of smaller objects, as well as not being a moon. So dwarf planets, like Pluto, share many traits with planets, but they haven't cleared their orbits. And that's the specific reason why Pluto got reclassified as a dwarf planet in 2006 when they made these changes. And that brings us to the end of today's lesson. Until next time.